Today in our video, we're going to talk about how we can simplify an expression that looks like this. If we think about what this is actually saying, we can rewrite it in a different way. So this is saying 2 times 6x plus 5. And we know that multiplication is just repeated addition, right? If we did 2 times 3, that's the same thing as 2 plus 2 plus 2, right? So we're going to rewrite that as repeated addition. So instead of 2 times 6x plus 5, we're going to rewrite it as 6x plus 5 plus 6x plus 5. So we have 6x plus 5 plus 6x plus 5, and then we can combine the terms that are like. So we know that we can't combine things if one of them has an x and one of them is just a constant. So we can only combine things that have x's together and things that don't together. So we have 6x and 6x. We add those together, we get 12x. And then we have 5 plus 5. We add those together, we get 10. The way that we can simplify this would be 12x plus 10. But if we don't want to have to rewrite this out, if this was like a 10 right here, we don't want to have to rewrite this 10 different times. There is a shortcut, and it's called the distributive property. And so how the distributive property works is we're going to take this 2 and we are going to distribute it into each piece of this parentheses. Because what's happening is it's saying 2 times this whole quantity. So we're saying it's 2 times 6x and also 2 times 5. Okay? I'm going to say 2 times 6x. 2 times 6 is 12, and then the I get 12x. And then 2 times 5. 2 times 5 is 10, and this is a positive 5, so it's going to be plus 10. So we can see that we get the same answer over here if we rewrite it into repeated addition. We get 12x plus 10. Same way if we distribute this 2 into this quantity here, 12x plus 10.
The distributive property is really nice for expressions like this, where maybe it would be hard to rewrite 4x minus 2y in terms being added x squared times, right? That seems a little bit more abstract. So the distributive property is really nice here. I can multiply x squared here. X squared times 4x. You can think of x squared as 1x squared. There's only 1x squared, so you do 1 times 4, which is just 4. X squared times x. If you remember exponent rules, x is the same to the first power, so I have 2 x's here being multiplied with 1x here, so altogether I have 3 x's, right? I can just add my exponents here. So x third, and then I can multiply this as well with this piece. It's important to remember the signs because this is a minus or a subtract 2y. I'm multiplying with negative 2y. So I got 1x squared times negative 2y, and that would be negative 1 times 2, 2. And with variables that aren't the same, I can just multiply them together. So x squared times y is x squared y.
So now we're going to practice using the distributive property on an example like this. So if you notice, the last 2 examples only had 2 terms in our parentheses, and this one has 3, but it doesn't matter. We're going to do this the exact same way. We just need to make sure that whatever number we have here on the outside are distributing to each term here in the middle. If we have 1/2 times y, we can just write that as 1/2 y. And then we have 1/2 times this negative 2x. So 1/2 times negative 2 is going to give me negative 1, because 2 times 1/2 is 1. And then the x can just go on the side there. And then 1/2 times 6 is the same thing as saying 6 divided by 2. So 1/2 times 6 is 3.
Negative 5y times the quantity 3y minus 8. Using the distributive property, I'm multiplying negative 5y with 3y, and I'm also multiplying negative 5y with negative 8. So looking at this first one here, I can multiply negative 5 times 3, which is negative 15, and then y times y is y squared. There are 2 y's being multiplied together. You could also use your exponent rules. I know this is 1 and 1. 1 plus 1 is 2. Negative 5y times minus 8, or negative 8, is positive 40. And you still have the variable here, y, so it's 40y. And that would be your simplified expression.
Now we're going to practice solving equations using the distributive property. The distributive property makes simplifying equations a lot easier, and so we're going to practice simplifying this equation so that we can solve it. So anywhere that I have parentheses and something being multiplied, I'm going to apply this distributive property. So I'm going to say 2 times x and 2 times 1. So 2 times x is 2x. Then I have this minus 1. So 2 times minus 1 is going to give me minus 2. And then I can just continue writing out what I have. I still have this plus 12 on the end. So plus 12 equals, and then I run into another set of parentheses that I want to use the distributive property for. So I have 4 times 10x, which is going to give me 40x. And then 4 times 7 is a positive 7, so that's going to give me 28. And then I still have this plus 4 on. Okay, so now that I've eliminated all my parentheses, I can combine the terms that go together. So if I look at this side of my equal sign, I have a 2x. Those are the only x's I have. And then I have a negative 2 and a positive 12. So I'm going to combine these. So I have 12 minus 2, which is going to give me 10, or negative 2 plus plus 12 will give me 10 as well. So 2x plus 10 equals, so over here I have a 40x. I'll have x's in either of these, so 40x, and then 28 plus 4 is going to give me 32. All right, and then if we think back to one of our first videos that we did, talked about solving equations, and whenever I have x's on both sides of my equal sign, the first thing I want to do is get all my x's on the same side. So if I have a 2x over here and a 40x over here, I'm going to move this 2 over to this side. So if I subtract the 2x from over here, I get a 0 pair, which is awesome, so I can cross that out. But then whatever I do to this side of the equal sign, I have to do to this side. And so I'll be left with 10 equals 38x plus 32. Okay, now that I have all of my x's on the same side, I can think about the story of x, what happens to x. We start with x all by itself, okay? Then we multiply it by 38, and then we add 32, okay? So we're gonna work backwards from this last step, okay? So if we added 32, we're gonna subtract 32. Whatever I do to one side, I gotta do to the other, and this gives me a 0 pair. So we'll subtract 32 from both sides. Now I have 10 minus 32, which is gonna give me minus 22 equals 38x, okay? So that step is done. All right, then I come up to this step, and I multiplied by 38. So the opposite of that is I'm gonna divide both sides by 38, and this becomes a giant 1, and so we're just left with x on this side. Negative 22 over 38, and you guys can totally put it into derivative just like this. Negative 22 over 38, that is an acceptable answer. Or if you wanted to simplify it, you could to negative 11 over 19. Either one of these will be the correct answer.
All right, what if we have an equation that looks like this? 5/3 times the quantity x plus 20 equals negative 16. Now, we've shown you in a previous video that you can undo both sides by multiplying by the reciprocal. So you can multiply by 3/5 here and 3/5 here. But you can also use the distributive property to help you solve for this. So let's try distributing this. We got 5/3 times x and 5/3 times 20. That leaves us with 5/3 x times, and then 5 times 20. Remember, this is like the same thing as 20 over 1. It helps you with multiplying fractions. So 5 times 20 gives you your top number, or your numerator, which is 100. And then 3 times 1 is just 3. So same as 100 over 3. And then that equals negative 16. So let's tell the story of x. We got x. What's happening with x? X is being multiplied by 5/3. After it's being multiplied by 5/3, then it's being added with 100 over 3. Let's use undoing to help us solve for this equation. So to undo adding 100 over 3, I'm going to subtract 100 over 3. Now this already looks like it's going to be a pain. So we can type this in our calculator, negative 16 minus 100 divided by 3. Or we could also change this so it has denominator of 3. So we could multiply this by 3 over 3. And now this is a 0 pair over here. So now we have 5/3 x equals negative 16 times 3 is negative 48 over 3 minus the 100 over 3. And now because our denominators are the same, I can just subtract across. So negative 48 minus 100 is the same as adding a negative 100. So this is 5/3 x equals negative 148 over 3. Okay, now we're on to our next step where we can undo times by 5/3. And remember, to undo multiplication by a fraction, we can multiply by its reciprocal. So to undo 5 over 3, I can multiply it by 3 over 5. And what I do this side, I gotta do to this side. So this side by 3 over 5. 3 divided by 3 is 1. 5 over 5 is also 1. So we're left with 1x equals, and we see here that my 3 on top and my 3 on bottom undo each other. So I'm left with negative 148 over 5. So you could write it as negative 148 over 5 in derivative, or you can also write it as negative 29.6. That also gives you the same answer.